Hello, what's the value of x? Given that you have x minus 3 in parentheses to the power of 4 equals 16, then let's have it to be solution from here. From here, we must note that we can have 16 to be equals 2 to the power of 4. So from here, we can have it as x minus 3 in parentheses to the power of 4 equals 2 to the power of 4. Then let us recall that when we have a to the power of m equals b to the power of m. So far they have the same power, this implies that a equals b. So this has the same power as this, so we can equate the base as x minus 3 will be equals 2, and so from here we are going to have x to be equals 2 plus 3, which will be equals 5. So finally, we can declare x to be equals 5. But from here, x equals 5 is not the only solution for this problem. Then let's see how to solve this. Mind you that we can have this 4 as the product of 2 times 2. So from here, let's replace 4 to be 2 times 2 here and here as well. Then we are going to have here to be x minus 3 in parentheses to the power of 2 times 2 equals 2 to the power of 2 times 2. Then recall that when we have a to the power of m times n, we can interchange the power to be equals a to the power of m and parentheses to the power of n. So when we apply it here, we are going to have this as x minus 3 in parentheses to the power of 2. We open under parentheses in power of 2. Then minus, let's take the whole of this term here to be 2 to the power of 2. Then in parentheses to the power of 2. Then let's set them to be equal 0. The moment we take this one here, we have here to be equal 0. But mind you that we have this place to be, let's express it as x minus 3 in parentheses to the power of 2, again in parentheses to the power of 2, minus 2 to the power of 2 give us 4 to the power of 2 equals 0. This one has power 2 and this has power 2. It's a difference of 2 square. When we have a square minus b square, this equals as a minus b multiplied by a plus b. So when we apply the difference of 2 square from here, we are going to have our a to be replaced as x minus 3 in parentheses to the power of 2 from here, and our b will be equals 4. Then when we substitute it here, we are going to have it as x minus 3 in parentheses to the power of 2, then minus 4 from here, then multiply by again x minus 3 in parentheses to the power of 2, then plus b plus 4 equals 0. Now for this term here to be equal 0 is either we have x minus 3 in parentheses to the power of 2 minus 4 to be equal 0, the first term in brackets, or we have this x minus 3 in parentheses to the power of 2 plus 4 to be equal 0. When either of this expression equals 0, the whole of this term we have here will be equal 0. Now let's solve this. Let's see case 1. We can express 4 as 2 to the power of 2. So here will now be x minus 3 in parentheses to the power of 2 minus 2 to the power of 2 equals 0. This also looks like we have difference of 2 square. Let's also rewrite this as 3 minus x minus 3 in parentheses to the power of 2 plus 2 to the power of 2 equals 0. Now, also difference of 2 square applicable here. When we have a square minus b square. And the reason is that this one has power 2, this one is also has power 2. We can have this as a plus b all in bracket multiplied by a minus b. Then when we make the comparison, we will discover that our a from here, because this has power 2, this has power 2, our a will now be x minus 3. And our b will be equals 2 from here. So then let's substitute it here. We are going to have x minus 3. Then we have plus b, meaning we are going to have it to be plus 2. Then a is x minus 3. Then we have minus b, here will be minus 2. Then we set it equals 0 from here. So we have x minus 3 plus 2 will give us minus 1. We have x minus 3 minus 2 will give us minus 5. Still equals 0. Now for this term again to be equals 0, is either we have x minus 1 equals 0, or we have x minus 5 to be equals 0. And so therefore, we have x to be equals 1. And likewise from here, we have x to be equals 5. Meaning that this x equals 5 justify the previous solution. Why x equals 1 is another solution for the problem given to us. Then let's solve for the case 2, where we have this case 2. This one is case 2, but we have this to be case 1. Now from this case 2, we have x minus 3 in parentheses to the power of 2. Let's take this to this side. We have it to be minus 2 to the power of 2. And this can be simplified as minus 4. Now to eliminate this power 2, we can take the square root of both sides as root of x minus 3 in parentheses to the power of 2 will be equals root of minus 4. Then recall that when we have root of minus a can be simplified as root of a multiplied by root of minus 1. And this equals, root of minus 1 equals I. So we have a root of a multiplied by I. So note that root of minus 1 always equals I, a complex number. Now from here we have this root to cancel this power 2. So we have x minus 3 to be equals root 4 multiplied by root of minus 1. Then root 4 is a perfect square, so we can have it as root of 2 to the power of 2 multiplied by root of minus 1 equals I. So we have x minus 3 equals this, we cancel out this, we have 2i. Because it equals positive or negative 2i because of its perfect square. So from here we have x to be equals positive or negative 2i, then plus 3. And so therefore we can write this as x to be equals 3 positive or negative 2i. So to check, we have x minus 3 in parentheses to the power of 4 equals 16. Then when x equals 1, let's verify if we are going to have 16. So from here we have 1 minus 3 and parentheses to the power of 4. Then it's still going to give us 16. 1 minus 3 will give us minus 2 and parentheses to the power of 4. Then it's still going to give us 16. Anytime when you have minus a to the power of even, so this will be equals a to the power of even plus, so when you apply it here, we have 2 to the power of 4 back, then equals 16. From here, 16 equals 16. Now, when x also equals 5, let's check again. We are going to have from here 5 minus 3 to the power of 4, then it's going to be equals 16. 5 minus 3 will give us 2 to the power of 4, which equals 16. So from here we have 16 equals 16. Now, so far the left hand side equal to the right hand side. X equals 1, x equals 5 satisfy the problem given to us. If you are new here, once again, don't forget to share, like, comments, and subscribe to our YouTube channel for more math tutorial videos. So we also have the complex solution where we have x equals 3 positive or negative 2i. We have this to be complex solution. We have this to be the real solution.